Today we will be looking at chapter number 8, Motion from grade 9. The first topic that we'll be looking at is motion along a straight line. So motion along a straight line is the simplest type of motion in which the motion is along a line. So suppose this is a line and this is O. O is the reference point from which the motion or the place at which the object was in the first, or it is called as the initial point. Now there are three final points of the object. The object moved all the way till A, came back to B, and then again to C. So these are the places where the object was. Now from this you can calculate the distance. Distance is calculated when you add the total length the object has traveled. So over here it will be 60. It traveled all the way till 60. Then 60 to 35, 35 to 20. So that's how you calculate motion or the distance. Now, an important thing to know in this concept is the difference between distance and displacement. Distance is the total path or the total amount of distance or the length a object has covered. That is from 0 to A. This is the total distance. So the total distance is 0 to A, then 60 to 35, then 35 to 25. So if you add all this together, you get the total distance. Now what is displacement? Displacement is the shortest distance that is covered by the object. So if the initial position was O and the object wanted to travel to C, the object didn't have to go all the way to A, then B, then C. It could have just went O to C. So this is the shortest distance. So that is what we call displacement. Now let's look at a few questions that are given in the textbook. So this is the first question. An object has moved through a distance. Can it have zero displacement? So what is displacement? The shortest distance. So if they are asking, if your answer is yes, how will you support it with an example? So if an object has moved a distance, then it has covered some length, no? Now if it has to have zero displacement, it should start at a point and come back at the same point. That is what we call as displacement, no? Start at a point, come to the final point. So initial and final point, if they are in the same place, then the displacement will be zero. That is in a circular path. So if the object moves in a circular path, the displacement is zero. The next topic is uniform and non-uniform motion. So motion are of two types, uniform and non-uniform. Uniform motions are the type of motion in which the object moves at a constant speed at a constant time. So if the object, let's take this example. If the object moves 5 kilometer. So if the object moves 5 kilometer in 1 second, that is the in uniform motion when the object moves 5 kilometers in 1 second. So each 5 kilometer the object travels in 1 second, then it is uniform motion. Now if the object moves 5 kilometer in the first second and 10 kilometer in the second, that is non-uniform motion. Non-uniform motion is simply just when the object moves at the different distances at same time. So same time, different distance. The quantity that you need to have in mind in this concept is speed. So what is speed? Speed is the distance traveled by the object in unit time. Unit time means in 1 second. So over here you can see the average time is the total distance traveled divided by total time taken. So you should know that speed is equal to distance divided by time. Then average speed is total distance divided by total time. Then you should know speed is described as v and distance is described as s and time is taken as t. So these are the symbols of this equation, that is speed is equal to distance divided by time. Let's look at this question for example. An object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. What is the average speed of the object? So you can see this is non-uniform motion. Why? Because in different seconds the object is traveling 16 meters. Now they're asking the average speed. So whenever they ask questions, the first thing is you need to write the formula first. So what is the formula for average speed? Average speed is equal to total distance traveled divided by total time taken. So then by that equation you can get what is the total distance that was traveled? 16 plus 16, that is 32 meters. Then what is the average or the total time taken? 4 plus 2, that is 4, 5, 6 seconds. So that is 32 divided by 6 will give you the average speed. And that will be approximately 5.33 meter per second square. Meter per second. So meter per second, that is meter divided by second, is the SI unit of speed. And instead of writing meter divided by second, if you take the second to the upper part, you will get second raised to minus 1. So this is the SI unit for speed. The next topic is speed with direction. So the rate of motion of an object can be more comprehensive if we specify its direction. So direction and speed together is what we call as velocity. Now the only thing you need to know is what is velocity. So velocity is initial velocity plus final velocity divided by 2. Or you can see v is equal to u plus v by 2. U is the initial velocity, v is the final velocity divided by 2. This will give you the average velocity. Then the other thing you need to know is speed and velocity both have the same units, that is meter per second raised to minus 1 or meter per second. These both are the same thing. While you go through this chapter, this question is very important because most of the questions come in this pattern. They only change the values, but these questions are important. This as well as this. The next topic is the rate of change of velocity. The rate of change of velocity is what we call as acceleration. So what is acceleration? Acceleration is the change in velocity divided by time, or acceleration is represented as a. Change in velocity is v minus u, that is a is equal to v minus u divided by t. So this kind of motion is also called as accelerated motion. Now if the velocity is in the right side or right direction and the acceleration is also in the right direction, then we take the acceleration as positive. If the acceleration is towards right and the velocity is towards left, then we take acceleration as negative. That is what is given in this paragraph. The SI unit of acceleration is meter divided by second square. Meter divided by second square, or meter second raised to minus 2. The next topic is the graphical representation of motion. So motion can be represented in various ways. The first type is the distance time graph. So what is distance time graph? It is when you take distance on the y-axis and time in the x-axis. So whenever distance in time comes like this, the slope or this line will be straight. And this line is what we call as speed. So distance divided by time will give you speed. So this is how you draw the distance time graph. Now when you look at this diagram, you can see the distance or the speed is constant. In this point it is constant. So if you see a straight line, then you should know this is uniform speed. So what is non-uniform speed? Non-uniform speed is when you get a curve. A curve means distance and time. According to distance and time, the speed is changing. So this is non-uniform. The next type of graph is the velocity time graph. So the variation in velocity with time for an object moving in a straight line is given like this. So this is how you draw an velocity time graph for uniform motion of a car or any object. Over here as well you can see the velocity time graph for a car moving with uniform accelerations. Here it is uniform motion of a car and here it is uniform acceleration. Now a CBSE favorite question is how do you find distance from this? So distance is the area given under this. So if you take the area of this rectangle, you will get the distance. How do you find area of a rectangle? Area of a rectangle is L into B, right? So L is what? L is 40 into B is, imagine this starts from 1. So 1 to 4 means 4. So 40 into 4 will give you the distance. Over here as well, you need to find the area to find the distance. That is the distance, the area of the square plus the area of this triangle will give you the total area of this figure. So this is how you get distance from velocity time graphs. Now these are the velocity time graphs of an object in non-uniformly accelerated motion. So if this is non-uniform acceleration, the slope will be downwards. When it is velocity and time, it will be downwards or it will be in a zigzag pattern. The next and a very important topic in this chapter is equations of motion by graphical method. So from the graphs that we discussed before, you can get three equations. The first equation is V is equal to U plus AT. The second equation is S is equal to UT plus half at square. The third equation is 2as is equal to v square minus u square. And over here, u is the initial velocity, v is the final velocity, a is the acceleration, and t is the time, and s is the distance. So these are the three very important equations from this chapter. Now there are derivations for these equations. So the first equation is when velocity and time is given. So whenever you have velocity and time, what equation do you use? You use the equation v is equal to u plus at. The second equation is when you have position and time. So when in the question they give you position and time, you use the equation s is equal to ut plus half at square. So this is the equation you use for position and time. Now, when you have position and velocity, you use the equation 2as is equal to v square minus u square. After watching these videos, please go through these questions because the NCERT questions are very important and will help you throughout your exams. So, go through all these questions as well. All the textbook questions are very, very important. And the last and again important topic is uniform circular motion. So circular motion, we already dealt circular motion before. In a circular motion, the distance or the displacement will be 0. Why? Because the initial and the final position will be same. So the displacement is 0 but the distance is not 0. That's an important point. Now what is uniform circular motion? So if an object moves in a circular motion, according to the time, that is in respect to time, then it is uniformly moving through the circle. Now this is an important thing. If we know the circumference of a circle, the radius is r and it is given by 2r. So the circumference of a circle is 2r. If the athlete takes t seconds to go once around the circular path of radius r, the velocity is given by. So this is another equation. V is equal to the circumference divided by the time. The circumference is 2r divided by t. So this is the equation for velocity in the uniform circular motion. This is a very favorite CBSE picture. They might give you this picture and tell you to identify what kind of motion is going on here and they might give you the values, that is radius value and then time value, etc. And when you get time or after watching this video, go through this paragraph. This is also important. So that's all about the chapter motion. Now let's look at the summary. So motion is a change of position. So this is the definition for motion. It can be described in terms of the distance or the displacement. Now what is distance? The maximum length that is traveled by an object. Displacement is the shortest length traveled by an object. Now the motion of an object can be uniform or non-uniform. Uniform is when the distance is in respect to time, and non-uniform is when the distance or the time is not respective of each other. Next, the speed of an object is the distance covered per unit time. So s is equal to distance. S is equal to distance divided by time, and velocity is the displacement per unit time. Next is the acceleration of an object is the change in velocity per unit time. So these are the definitions of motion, speed, acceleration, velocity, etc. And then where u is initial velocity of the object and t is time, v is final velocity and t is seconds. So these are the important things in these equations. Next is if an object moves in a circular path with uniform speed, its motion is called as uniform circular motion. After going through this chapter and reading each and every line, go through all these exercise questions. These questions are very, very important as they might come for exam. This graph is also very important. So what they might ask is which has the most distance and time, no? Distance and time will give you speed. Which of this has more speed and stuff, see? Traveling the fastest, that is traveling or the most speed, and all the three at the same point of this. So these questions are very, very important. So this is all about the chapter motion from grade 9. If you like this video, please like and subscribe, and thank you for watching.